The universe has a sick sense of humor. You could build the most perfect spaceship imaginable, faster than anything we've ever dreamed of. No fuel problems, no mechanical failures, no crew going crazy from isolation. A perfect machine, and it would still fail, completely, utterly, irreversibly. Not because of bad engineering, not because of bad luck, but because of something so fundamental, so baked into the fabric of reality itself, that no amount of genius can outsmart it. And here's what keeps me up at night. We are already sending that message into the void right now. Every signal, every probe, every hopeful broadcast, aimed at planets that by the time anything arrives may have been dead for longer than life has existed on Earth. The cosmos doesn't care about your arrival time. And before you say it, yes, we know space is big. That's not the point. Everyone knows space is big. We say it, we nod, we move on. But knowing a thing and truly feeling its consequences are two completely different experiences. You can know that the ocean is deep and still be completely unprepared for what lives at the bottom. So, let's not just acknowledge the size of the universe today. Let's follow it. Let's trace exactly what it means, not for some abstract future civilization, but for the very specific problem of ever finding another one, because when you actually sit with the numbers, when you let them breathe and expand and do what they do, something quietly horrifying starts to take shape. Not a dramatic horror, not a movie horror, the kind that arrives slowly like a cold you didn't notice until you were already sick. Here is where we start. The nearest star to our sun is Proxima Centauri. It sits roughly 4.2 light years away. That number sounds manageable until you understand what it means in practice. A light year is not a unit of time. It is a unit of distance. Specifically, the distance light travels in 1 year. Light moves at about 300,000 kilometers per second. In 1 second, it crosses a distance roughly equal to going around the Earth 7.5 times. In 1 year, that same light covers about 9.5 trillion kilometers. Proxima Centauri is 4.2 of those years away. That is almost 40 trillion kilometers. Our fastest spacecraft ever launched, the Parker Solar Probe, reaches speeds of around 700,000 kilometers per hour under the right conditions. At that speed, a trip to Proxima Centauri would take somewhere in the neighborhood of 6,500 years, not 6,500 days, years. You would need to start that journey roughly 4,500 years before the birth of Christ just to arrive today. And Proxima Centauri is the closest star we have. It is our next-door neighbor. Everything else is farther. Most things are incomparably farther. But that's just the engineering problem. That's just the distance. And as I said, the distance is not actually what we're here to talk about. The distance is just the stage. What matters is what happens on that stage while the ship is crossing it. Think about a civilization the way you think about a fire. A fire is not a thing. It is a process. It takes fuel. It produces heat and light. And when the fuel runs out, or when something disrupts it, it stops. You cannot visit a fire that burned out 1,000 years ago. You can see the ash. You can read the shape of the char on the ground. But the fire itself, the thing you came to see, is gone. Civilizations are the same. They are not static objects sitting in space like mountains or moons. They are dynamic, fragile, unstable processes. They require very specific conditions to exist. They can be disrupted by a staggering number of forces. And unlike stars or planets, which operate on timescales of billions of years, civilizations, at least the only example we have, operate on timescales of thousands or perhaps tens of thousands or perhaps hundreds of thousands of years at most. Maybe more if we're lucky, maybe far less. We genuinely do not know. And that uncertainty is load-bearing in everything that follows. So now put those two things together, the timescale of travel and the timescale of civilizations. You are sending a ship, even your perfect ship, across a journey that will take thousands of years, at minimum tens of thousands of years realistically, and potentially hundreds of thousands of years depending on the target. And you are aiming it at a process that may not last that long. You are not aiming at a rock. You are aiming at a flame. And the wind has been blowing for the entire duration of your flight. Now here is where it gets more specific and more uncomfortable. When we search for life, when we look out into the galaxy with our radio telescopes and our spectroscopes and our carefully constructed signal detection algorithms, we are not looking at the present. We cannot look at the present. Physics forbids it. When you look at a star 100 light years away, you are seeing that star as it was 100 years ago. The light hitting your eye left that star before you were born, before your parents were born. The image you are seeing is a photograph taken by the universe itself, and it is 100 years old. If something happened to that star last week, if it exploded, if it went dark, if it somehow flickered, you will not know for another 100 years. The information is on its way to you, but it has not arrived. You are always looking into the past. Always. There is no exception. There is no workaround. The speed of light is not a technology problem. It is a law of reality, and it applies to everyone in the universe without negotiation. This means that when we detect something interesting, a strange signal, an unusual atmospheric signature, a pattern that looks like it might be artificial, what we are actually detecting is a ghost. We are seeing a record of something that existed. Whether it still exists is a completely separate question, and it is a question we cannot answer from here. We can only answer it by going there. And going there takes time, more time than we can currently fathom. Let's follow a scenario. Not a fanciful one, a conservative one. Suppose tomorrow we receive a signal from a star system 400 light-years away. The signal is unambiguous. There is no doubt. It is artificial. It was made by minds. The scientific community confirms it, the world celebrates, and humanity begins planning a response and eventually a mission. The signal we received left that star 400 years ago, meaning whatever sent it was alive and broadcasting in the 1600s. That is already a significant gap. But now we begin building our ship. Even in this optimistic scenario, construction, testing, and launch takes another 100 years. Now we launch. Our perfect ship, let us say it travels at 1% of the speed of light, which would be an extraordinary achievement, far beyond anything we can currently do, would take 40,000 years to reach that star. 40,000 years. We launched in the 2100s. We arrive in approximately the year 42,000. And the civilization we are traveling toward was last confirmed to be active in the year 1600. We have not had contact in over 40,000 years. We have no idea what has happened in that time. We are arriving at a destination based on the oldest information imaginable, with no updates, no pings, no way to know whether what we are looking for still exists. Does it strike you as likely that they are still there? That in 40,000 years nothing changed? That no asteroid hit, no resource collapsed, no internal conflict consumed them, no disease swept through, no shift in their star's output made the surface uninhabitable? That they simply waited exactly as they were for 40 millennia? Put it another way. 40,000 years ago on Earth, our ancestors were painting animals on cave walls. They had no writing, no cities, no agriculture, no metal. If something had sent a ship toward Earth 40,000 years ago, based on a signal it detected, it would arrive today to find a world that looked nothing like what it was aiming for. And it would consider that a good outcome because at least we are still here. Civilizations do not have to survive to make the arrival useless. They just have to change. And 40,000 years is more than enough time to change beyond all recognition, collapse entirely, or evolve into something so different that the original signal is essentially irrelevant. This is the trap at the heart of interstellar contact, not the distance, the time. Time is the real barrier, and it is one that no engine, no fuel source, no theoretical breakthrough in propulsion can fully solve. You can get faster. You can get much faster. You can, in the most optimistic physics allows, approach the speed of light, but you cannot exceed it. And even at the speed of light, the problem does not go away. It just gets smaller. A ship traveling at the speed of light from Earth to a star 1,000 light-years away still takes 1,000 years to arrive. The civilization on the other end had 1,000 years to live or die, thrive or collapse, stay or leave, while that ship was in transit. Light speed is not a solution. It is merely the best possible version of the same problem, and there is something else. Something that does not get talked about enough. Something that makes the whole picture darker. We tend to imagine the search for extraterrestrial intelligence as a two-way relationship. We look for them. They look for us. We find each other. Mutual discovery, a conversation. But that image contains a hidden assumption that both parties are looking at the same time. Think about what that requires. You need a civilization to exist, to develop the technology, to send detectable signals, to actually send them, and to still be sending them at the exact moment that we are capable of receiving them. That is a remarkable number of requirements to satisfy simultaneously. The universe is 13.8 billion years old. The window in which any given civilization is both technologically capable and actively broadcasting might be a few thousand years, a few tens of thousands, if they are very long-lived and very stable. Against a backdrop of 13.8 billion years, that window is nothing. It is less than a blink. Two civilizations trying to find each other through the noise of an ancient universe are like two people trying to light a match in the dark at the same time on opposite sides of a continent, each unaware of the other's schedule. The overlap problem, that is what some researchers call it, and it is genuinely unsolved, not unsolved as in we are working on it, unsolved as in there may be no solution. You cannot force two independent timelines to align. You cannot control when a civilization arises, when it broadcasts, or when it falls. These are outcomes driven by geology, biology, chemistry, and chance. They do not coordinate with each other. They do not wait for convenient timing. And the probability that any two civilizations find themselves in the right overlapping window, both existing, both capable, both looking, both within range, is small in a way that is hard to put into words without it sounding like an excuse. But here is where I want you to really sit still for a moment, because we have been talking about other civilizations as the variable, as the unknown, and that is the right framing for most of this conversation. But there is a version of this problem that hits closer to home, a version where we are the variable, where we are the unknown, where the ship heading toward us, if there is one, is already in transit, aimed at a version of Earth that no longer exists. Think about what Earth looked like 100,000 years ago. Anatomically modern humans existed, but barely. No language complex enough to transmit knowledge across generations at scale. No accumulated technology. No civilization in any recognizable sense. If something had aimed a ship at Earth 100,000 years ago based on some biosignature that suggested interesting chemistry, it would arrive today to find something staggeringly different from its target. It was not aiming at us. It was aiming at our ancestors. We are an accident that happened in transit. Now flip the timeline. What does Earth look like 100,000 years from now? You cannot answer that. Nobody can. But consider the range of possibilities. We may be gone, not dramatically, not necessarily from some catastrophe, but simply because species do not last forever. The average mammal species persists for about 1 million years before it either goes extinct or evolves into something different enough to count as a new species. We have been around for roughly 300,000 years. We are not old, but we are also not guaranteed to last. At the low end, a particularly bad century, or a particularly bad decade, could shorten that timeline dramatically. At the high end, perhaps we expand, adapt, and endure for millions of years. But in what form? Biological humans as we exist today? Almost certainly not for anything like 100,000 years. The being that might receive an alien ship in the year 100,000 is not us. Not in any meaningful sense. It has our DNA as an ancestor. That is about all we can say. So the ship that leaves another star today, aimed at the biosignature of Earth, is already aimed at a ghost. It just hasn't become a ghost yet. This is not despair. I want to be clear about that. None of this is an argument that the search is pointless, or that contact is impossible, or that we should stop looking. That would be the wrong conclusion. The wrong conclusion would be to look at the size of the problem and decide the problem isn't worth thinking about. The right response, the scientific response, is to look at the problem clearly, without flinching, and understand exactly what it means for how we search, what we search for, and what we expect to find. Because once you understand the timescale problem, the overlap problem, the ghost problem, you start to realize that the most likely form of contact, if contact ever happens at all, is not a conversation. It is an artifact, a remnant, a signal that has been broadcasting for so long, sent by something so stable and so deliberate that it has outlasted the civilization that sent it, or perhaps a physical object, a probe, a marker, something left behind precisely because its builders understood that they would not be there when it was found, a message in a bottle thrown into a sea so vast that the bottle itself might outlast the civilization that threw it and the one that finds it. That image should change how you think about the search, because if we are looking for active civilizations, things that are alive and broadcasting right now, we may be looking for the wrong thing. The universe may be full of evidence that is not alive, evidence that exists precisely because something anticipated the timescale problem and built for it, And that changes the questions we ask. Instead of asking where is the signal, we should also be asking where is the monument. Instead of asking who is broadcasting, we should also be asking what was left behind. There is a concept in this space that does not get nearly the attention it deserves. Directed panspermia, the deliberate seeding of life across stellar distances. The idea is not mainstream, but it is not fringe either. The logic goes like this. If you are a civilization that understands the timescale problem, that understands that no ship you send will arrive in time to find another living civilization, and that no message you send will reach someone who can respond before you are gone, you might decide that the only meaningful legacy is biological. You might decide to send not a message, not a ship full of diplomats, but a payload of life, seeds, spores, microorganisms engineered to survive the crossing and to seed chemistry on a suitable world, not to make contact, not to colonize, just to continue something, to leave a mark on the universe that outlasts your own brief window of existence. And here is the thought that is very hard to shake once it occurs to you. What if someone already did that? What if the life on Earth, the specific, strange, improbable chemistry that underlies every living thing on this planet, is not native? What if it is a message, not a radio wave, not a signal, a biological message sent by something that understood it would never see the response, aimed at a planet that looked promising, launched into the dark with the full knowledge that the sender would be gone long before anything grew? We cannot currently answer that question. The evidence is ambiguous, but the logic that would motivate such a decision, that logic we can follow, that logic we can understand. Because we are beginning, just barely, to understand the timescale problem ourselves. We are starting to see, for the first time in our history as a thinking species, the full shape of the barrier between us and everything else in the universe. And it is not a wall of distance, it is a wall of time. It has always been a wall of time. Every civilization that ever existed, if any others have, faced this same wall. Every one of them looked up at the same stars and asked the same question. Every one of them eventually built the instruments to listen, to search, to reach. And every one of them arrived sooner or later at the same quiet, devastating realization that the universe is not hostile. It is not trying to keep us apart. It simply does not care about synchronization. It does not arrange for civilizations to arise on the same schedule, to develop at the same pace, to broadcast on compatible frequencies at compatible times. The universe is indifferent to the problem of contact in the most complete way possible, and indifference at this scale is harder to argue with than opposition. But let us push further, because we have not yet talked about the most unsettling implication of all. We have been assuming, throughout this entire conversation, that the civilizations we might find are roughly like us. Biological, planet-based, operating on human timescales of thousands or tens of thousands of years. And maybe some of them are, but that assumption may be the most parochial thing about our entire approach to this search. Consider what we ourselves might become in a few hundred years. Not thousands, hundreds. We are already building systems that think, systems that learn, systems that process information at speeds and scales no biological brain can match. The transition from biological to post-biological intelligence, from creatures made of carbon to processes running on something more durable, more scalable, more flexible, may not be thousands of years away. It may be closer than we want to admit. And once that transition happens, the timescale problem changes shape entirely. A biological civilization is fragile in the ways we have described. It needs food, water, atmosphere, temperature stability, a stable star. A post-biological civilization needs energy and substrate. Those are easier to find. They are available in far more places, in far more forms. A post-biological civilization might operate for millions of years. It might spread not by sending ships, but by sending information. Compressed, encoded, ready to be reconstructed anywhere the right conditions exist. It might not live on a planet at all. It might live in the spaces between stars, harvesting whatever energy trickles through the dark, patient in a way no biological creature can be. If that is what advanced civilizations look like, and there is no physical reason it could not be, then we are looking for the wrong thing in the wrong way for the wrong reasons. We are scanning for the radio emissions of creatures like us, carbon-based, planet-bound, broadcasting on frequencies that make sense to biological minds. And the things that are actually out there, if they exist, may have moved so far beyond that profile that our searches pass through them like light through glass, transparent, undetected, not hidden, just fundamentally different from what we are equipped to recognize. This is not a comfortable thought. It is not supposed to be. Comfort is not the goal here. Clarity is. And the clearer you look at the structure of this problem, the more you realize that the famous silence of the universe, the fact that after decades of searching we have found nothing, heard nothing, detected nothing unambiguous, may not be a mystery at all. It may be the answer. Not silence as in nothing is there. Silence as in nothing is there in the form we are looking for. The universe may be speaking in a language we have not yet learned to hear, or it may have spoken long ago and the echoes have since faded below the threshold of our instruments. Or the conversations may be happening right now in a medium so alien to our biology and our physics that we lack even the conceptual framework to recognize them. And even if we built the perfect ship, the dream ship, the ship that solves every engineering problem, that crosses 40,000 light years in what feels like an afternoon, we would still arrive with the same fundamental uncertainty. We would still be stepping out onto a world that we know only as it was, not as it is. We would still be the latest frame in a movie that started without us. The ship does not solve the problem. The ship is not the answer. The ship is just a faster way of arriving at the same question. There is a particular kind of loneliness in this realization, not the loneliness of being alone in the universe. That kind of loneliness is straightforward. It has a clean shape. You are alone. You accept it. You move on. The loneliness embedded in the timescale problem is different. It is the loneliness of knowing that you might not be alone, that there may have been others, that there may be others now, that there may be others coming after, and yet being permanently, structurally, physically prevented from ever sharing the same moment with any of them. You are separated not by space, but by sequence. You exist in your window. They exist in theirs. The windows do not overlap. The universe is full of stories that will never meet each other. Think about that for a moment. Not abstractly. Really think about it. Every civilization that has ever arisen in this galaxy, if they arisen, lived its entire arc without any knowledge of the others. It was born, it grew, it asked the same questions we are asking, it built the same instruments, it listened, it searched, it found nothing, and it ended. And somewhere else, at some other point in the 13.8 billion year history of this galaxy, another one did exactly the same thing. And another. Each one convinced, perhaps, that it was alone. Each one broadcasting into a silence that was not really silence at all. Just a silence in the direction of its particular moment. We are one of those fires. We are burning right now. We do not know how long we have. We are sending our signals out into the dark, radio waves, light pulses, the leaking transmissions of a civilization that has not yet learned to be quiet. And those signals are moving outward at the speed of light in every direction, an expanding sphere of evidence that we existed, that we thought, that we wondered. Some of those signals have already passed thousands of stars. Most of those stars have planets. Some of those planets have the right chemistry. None of them, as far as we know, have answered. And by the time our signals reach the interesting places, the places where the chemistry gets really promising, we will have been gone or changed beyond recognition for so long that the answer would arrive to a world that no longer remembers the question. The cosmos doesn't care about your arrival time. It never did. It was never arranged with arrivals in mind. It is not a destination. It is a process, unfolding across scales of time so vast that every civilization within it is essentially alone, not because the universe is empty, but because the universe is too old, too large, and too indifferent to arrange for anyone to arrive anywhere on time. And yet we keep looking. We keep building the instruments. We keep refining the searches. We keep asking the question, even knowing what the question costs, even knowing what the silence might mean, not because we expect to find someone waiting, but because looking is what minds do when they understand the size of the dark, because the search itself is the proof that something here on this small warm rock decided that the loneliness was worth examining rather than ignoring, that the question was worth asking even without a guaranteed answer, that the fire, however brief, was worth burning as bright as possible. And somewhere out there, in some window we will never share, in some moment we will never reach, something else may have made the same decision, may have looked at the same dark, may have built the same instruments, may have asked the same question and heard the same silence and kept going anyway. We will never meet them. The math doesn't allow it. But we are, in the most precise and literal sense possible, asking the same question at the same wall, and that, in a universe this large and this old and this indifferent, is the closest thing to company we are ever going to get.